Hello everybody, and welcome to the beginning of section 1.4. We're looking at page 23 in the workbook, and the topic of this section is more about the derivative of a function. Okay, what we've talked about so far is we've thought of the derivative as something that happens at a point. Okay, it's a way of representing the rate of change of a function right at a particular number. And in this section, we're going to change our perspective a little bit and talk about the derivative globally. Think of it as an entire function that gives us information about the rate of change of a function all at once. Okay, so to just kind of get the idea of what this is all about, let's start with the preliminary example here. Okay, let's read this together. So below and to the right, we're given the graph of a function. Okay, that's what we're seeing here. And they'd like us to use a straight edge and draw in tangent lines, estimate their slopes, and then use that to fill in the table to the left here. Okay, because remember, the derivative is about a bunch of slopes of tangent lines. Okay, and so what we're going to do in this video is to get you started on this. I'd like to see if we can maybe fill in the first two entries of this table, show you what this is about, and then ask you to fill in the rest of the entries on the table on your own. All right, so let's start with x equals -3. To find f prime of -3, that by definition is the slope of the tangent line to our function at x equals -3. So we'll find -3 and the point on our function. And I'm going to take out a straight edge now. You can't see this, but I've got a straight edge in my hand here. And I'm going to draw my best approximation of what the tangent line would look like at 3, so maybe about like that. Okay, and then the question is, what would you estimate the slope of that tangent line to be? Okay, well, we could do that by maybe picking a couple of points, nice numbers on that line. Notice that if we measure the rise over run, we went up 2 and over 1, so the slope of that should be 2 over 1, which is 2. And that's our value of f prime of 3. Okay, and now, same idea for -2. We're going to find the point where x is -2 on our curve, take out that straight edge, and draw the best tangent line we can. Okay, it's difficult to be really exact on this, so just do the best that you can to draw in a tangent line. Okay, there's my best guess as to what the tangent line would look like. Okay, and again, we want to estimate rise over run. Okay, so I'm going to pick a couple of points, maybe this one, that's x equals -2 and x equals 1. And if you look at how far up and over you go, to me that looks like an increase of about 1 in the y direction, and then an increase of, let's see, we go from -2 to 1, that's 3. So the slope should be 1 over 3. Okay, and again, that's just an estimate. That's our best estimate of what the derivative at -2 is. Okay, so hopefully you kind of get the idea. This is the end of this video, and next thing on your list is to fill in the rest of the entries of this table. Okay, so see what you can do with that.